Peace be upon you and God's mercy and blessings. God willing, we will see together how I can make or use this time. We will see another circuit together. The circuit we have starts by routing the wires from the city box to the local control cabinet, and it enters and looks like this. In this case, I work on the fix. After that, I exit with 3-phase and neutral from the LCC to the protection panel or metering panel and enter the slide link TP of the OTA6T type. This is the terminal block responsible for the shorting and isolating process. We notice here that each phase has only 2 thermal blocks, unlike the function we explained in the previous lecture, which now appears on the screen. If you haven't watched the lecture before, please follow it immediately. Then I exit with 3-phase and enter the slide link TP, which is the terminal block responsible for the bypassing process. Bypassing TP is used in the case where I have 2 protection relays or 2 metering devices connected in series on the same CT secondary. For example, when you have the overcurrent and breaker failure as 2 separate relays connected in series, or when you have the BCU, which is the Bay Control Unit, and the DSM, which is the Dynamic System Monitoring, connected in series. Then I exit to the test switch and from there to the first device, and then return again to the test switch. Then the bypassing TP, from which I will go to the second device, and finally return with the neutral wire. Now we will start the practical session together, but the most important thing is not to forget our rule. Shorting must be done before isolating. Now we will start the practical session on the city shorting and isolating facility. As you can see, this is the demonstration of the circuit we explained, and we said that our circuit starts with a 3-phase current transformer that connects the wires from the city box to the LCC. As for entering the FX type TP, of course, this is not the type used, but the type used is now in front of you on the screen. After that, I exit from the LCC and go to the protection panel or metering panel and enter the slide link TP of type OTA6T. Its function is city shorting and isolating, and I exit from it to another slide link TP whose function is bypassing. From there, I go to the test switch, and here I have the ABP-FT test switch. Finally, I have 2 protection devices or 2 metering devices, and here I am using 2 power meters. Very good. Now, I want to talk about 3 things. The first thing is the process of shorting and isolating using the thermal block. The second thing is the process of shorting and isolating using the test switch. The third thing is a tricky point during the shorting and isolating process. Very good. Okay, at the beginning, instead of the current transformer, I will use the current generator output from any secondary injection test kit, like the Freya 300 or CMC 156. So here I have my 3 phases: red, yellow, blue, and black. Very good. Okay, now I will start injecting 3-phase current with balanced currents of 1 ampere on the 3 phases, with a 120-degree shift between them. But before I inject into my circuit, I need to ensure that my circuit is in the normal position. So of course, here I have the shorting and isolating type, and its normal position is that terminals 2, 4, 6, and 8 are closed, and terminals 1, 3, 5, and 7 are open. So the idea of open is that you will find the link on your right side, and for closed, you will find the link on your left side. As for the finger type test switch, you will find all the fingers closed. I will start injecting my currents. Here, I have set the ratio on the power meters to be 600 to 1. As we can see, the currents are balanced on the 3 phases. It is closed on 3 phases. Very good. As for the shorting process, we agreed that you will do it by first closing 1, 3, 5, and 7, and then opening 2, 4, 6, and 8. So, I start by bringing link number 1 on the left, and make sure everything is in order. Then, I have terminal number 3, followed by terminal number 5. Then, here is terminal number 7, very good. After that, I proceed to open terminal number 2, followed by terminal number 4, then terminal number 6, and finally, terminal number 8. This sequence ensures that all necessary terminals are accessed in the correct order. In this way, of course, we saw that I did a shorting on the CT circuit and isolated the power meters from the secondary circuit of the CT SAT-ED. Of course, I have the Freya 300 or the CMC 156, both of which are considered as the CT secondary circuit. What does this mean? It means that if I had made any wrong step here, something like the Frija would indicate that there is high impedance on its circuit, or even the SIMC would also give you a warning that you have high impedance. Very good. So I want to start normalizing the circuit again. This process is crucial for ensuring optimal performance and safety. I begin by closing before opening, meaning I start by closing numbers 2, 4, 6, and 8, which is essential for maintaining the correct sequence. Then I proceed to open number 1, making sure to check the tightness very well. This step is vital to ensure that all connections are secure and functioning properly. And approximately 5 and 7, this is the first point. The second point I want to address is the topic of shorting and isolating through the ABPFT test switch. Of course, here I have my fingers. I can open the CT fingers one by one, but we must know that here in your fingers, there is always a finger such that if you open any finger, you will find all its fingers open together. Whoever I am now, or this, of course, it is only connected to someone. Who is for me? This is me with this movement. When I open my thing, what did I do? I am doing it to whoever is coming and going, number 1. It's going to number 1, and thus the planes here shorted. So they only returned from the trail, bypassing TP, and went to whom? They went to meter 2 alone, just like that. Okay, did I do isolating? No, I didn't do isolating. We agreed that to do isolating, you need to bring your test plug and ensure you are entering the test plug here to isolate the first power meter and ensure you connect your test leads here to test your power meter, or if it was, of course, a protection relay. Why do I place the metallic wa'ukanu and open all the fingers together? This is the third task I wanted to talk about. The idea is quite simple, guys. When you open a finger alone, for example, you have a finger here, as you can see, you will find that this phase's current has been shorted and cut off from whom? From this power meter or from this protection device. If you short phase number 1, you close number 1 and you close number 3. Shorting, right? Say, for example, on phase number 1, you closed, for instance, number 1. And you started, of course, to close, for example, number 3, as we can see here, right? And then I will start closing number 5. I keep doing this during this process. As you can see what happened here with the currents. The currents here have been affected, right? So of course, when you have this here, it depends on the current, like this or otherwise, and in this case, they might enter for me. They might enter for me. Therefore, you must ensure that in this case, when you are doing shorting and isolating, you must keep in mind that you are isolating the binary output related to tripping. So even in the case of shorting and isolating, you can take steps when performing protection relay. As we said, a trip command might appear by mistake. And with this, folks, we have completed the experiment